Assalamualaikum warahmatullahi wabarakatuh and very good day. My name is Ahmad Baihaki bin Muhammad Najib Al-Puan and these are my fellow team members Ahmad Shahmi, Ahmad Hafizuddin and Muhammad Hafiz. Today we will be presenting application of slider crank mechanism.
The slider crank is a mechanical linkage that converts a rotary motion into a linear motion or vice versa. The crank is driven by a rotary motion, typically provided by an engine or a motor. For this project, we use an actuator, and this rotation is translated into a linear motion of the slider. Achieving a precise control over velocity and angular velocity is essential for optimal performance in motion control system across industries. In this project, the linear actuator was essential because it delivered a steady and accurate linear motions. Their accurate positioning capabilities serve as a solid foundation for achieving the desired control and precision in both horizontal and vertical axes. The real-life application for the slider crank include the reciprocating compressor and piston pump. The objective of the project is to convert the linear motion to a rotary motion. The slider crank mechanism is often used in convert the reciprocating motion of a piston into a rotary motion, as in internal combustion engine. Secondly, we want to increase the power output. In an engine, the slider crank mechanism can be optimized to increase the power output by improving the efficiency of the combustion process and reducing the frictional losses. The problem statement states that the mechanism must be designed to follow a precise path with a specific motion characteristic, minimize the energy losses, withstand forces and stresses, operating reliably, and minimize the noises and vibrations.
Alright, next we're moving on to the theory part of this project. We have been given the past year dynamic question to solve for the angular velocity of link AC and to calculate the velocity of collar D. As we can see here, the rotary motion of link AC where the point C can be calculated and converted to uh, Y component in order to obtain the value of velocity collar D. This question have been altered in order to fit with our 12-volt actuator. Several components have been used to measure angular velocity value by using the MPU 6050 and at the point of link AC, specifically at point B, and to measure the velocity with ultrasonic sensor at the bottom rail of the collar D. Alright, next we're going to the theoretical solution. To calculate the angular velocity of link AC and velocity of slider D. So in this case, velocity of actuator was observed uh, from the distance travel and the time taken, which is as we can see here is 0.079 meter per second.
Alright, this is the methodology of the project where we built in process flow diagram. The project started with project selection where we need to choose the question from past year question, dynamic examination. Then we need to come up with problem statement and the objectives. Next, design process, we use CATIA to get the actual dimension of the project that will be produced. After that, the procurement of the components where we identify and select suitable materials and components for the project. We purchase the components from reliable source and online store and also reuse the previous semester project components. And then we use 3D printing to produce few specific parts for slider crank mechanism and need to make sure the product in suitable tolerance with the CAD design. Next, we assemble the slider crank mechanism using the required components and 3D printing parts. Follow the design specification. For coding process, we use Arduino programming language to code necessary instruction to control the prototype. Testing process is where we conduct a test to ensure the assembled prototype functionality. For data collection, we conducted experiment to collect data and evaluate performance of the prototype. And lastly is the data presentation to compare the data obtained from theoretical and experimental. This is our prototype, which we follow like in the past year question, but have few modifications to suit our required components. We have slider A, link AC, point B. Point B is where the actuator is located to move the entire system. And then rail C and collar D. We put sensor MPU6050 on link AC to measure the angular velocity of that part. And then ultrasonic sensor used to detect the distance travel by quality. And from the distance, we also can get the velocity of quality by include the suitable formula in the coding and display on LCD screen. And then keypad function as input for actuator to start, move, and stop. For list of components, linear actuator is the main components to move the entire system. Motor driver to control the direction of the linear actuator by amplifying and translating control signals from the microcontroller. Ultrasonic sensor to measure the distance traveled by quality. Wire jumper, screw and bolt, and nut used to fasten the components to the main base of the prototype. Gyroscope our GY521 MPU6050 to measure the motion and acceleration. In this project, we use to measure the angular velocity of link AC. LCD used to display the output measured by the sensors. Membrane keypad 16 keys to key in the input to the system. Ball bearing used on the rotating parts, and 12-volt adapter to power up the system. For costing, this is the list of the components we use in the product development. Actually, we were able to use some components from previous semester project, which helped us to reduce cost. However, to determine the overall project cost, we still need to consider the actual market price of the parts we use, so ensuring an accurate assessment of the project expenses. Overall, the total cost for this whole project is about 347 ringgit and 60 cent, including the parts we reused from the previous project from previous semester.
Bismillahirrahmanirrahim. I will continue on the presentation on the product design. After the process of selection, we initially came up with this design. However, the design is not practical as there are some problems such as too many use it used too many build elements, and the slider is imbalanced at point C where it travels in both X and Y axis. Therefore, we need to improvise the design better. So this is the final design we come up with, and as you can see in the design, we fix all the issues stated from the previous design, and we also actually utilize the used actuator for the project, which is much more efficient and require less calculation compared to printing the piston part one by one. So the slider design on top revised as well to actually smoothen up the movement and improvise the slider balance. Okay, this is the bill of the material for the component, and as you can see, the project actually contains 19 components, including all the electronics. The material used for the component are mostly PLE, which is 3D printed. For the body, we use wood, while the slider rail we use steel to ensure the top slider is hold steady enough. The ultrasonic sensor is embedded in the top slider holder one, which is at the bottom of the prototype.
Alright, next we reach to the discussion part. The data shown is linear velocity and the angular velocity are both for the theoretical and experimental value, which is the 0.164 meter per second, and the angular velocity is 0.58. Both the average value for the 5 iterations. The percentage of error for linear velocity is 22.58%, and the percentage error for the angular velocity is 3.34%. By increasing the iterations, uh, from the experimental data can improve the accuracy and precision of the statistic of the measurement. The percent error is calculated for determination of how possible values may deviate from the theoretical value due to several factors such as the limitations of the 3D printed slider crank and the inconsistent tolerance.
Next, we proceed to the limitations of the project. Firstly, is the size of the shaft at the collar D was not fully fit, indicates there will be resistance when the collar D move. Secondly, the angle of the rotating point in the experiment may be different from the theoretical due to the size difference of the prototype from the theoretical. Uh, Next, the slider A used a rectangle shaped block instead of roller as shown in the theoretical. The theory influenced the speed of the system due to its resistance. And lastly, the ultrasonic sensor and the MPU accelerometer position may not be accurate to fully capture the exact value of the parameter.
For the conclusion of this project, the combination of Arduino system and 3D printing can be utilized in order to observe and to study the slider crank mechanism's function and structure. It is also a big help to better understanding in the dynamic mechanism. Next, the product system has certain constraint and still has a room for enhancement to ensure the acquisition of precise data. For example, the material can be changed from PLA to stainless steel or aluminium in order to increase the mechanical strength. Next, both experimental and theoretical analysis can be employed to examine the kinematic characteristics of the slider crank mechanism. That's all from us. Thank you for your attention.
So this is our product demonstration. When we press T, the actuator will move upwards alongside with collar D and slider C, while slider A will move to the right. And then we just press 6 to stop the system. We continue the system when we press 9. The actuator will move back to the original places alongside with collar D, slider C, and slider A. So the parameter that we get the linear velocity uh, with 1.69 and when angular velocity with 0.47 radian per second.